Order of operations. So I came across this question online the other day, and I was interested to see how many incorrect answers that were actually posted. So 7 plus 7 divided by 7 plus 7 times 7 minus 7 seems easy enough. Here are some responses that I found. This person from New York said the answer was infinity. Okay, and this is their reasoning. Another person from Colorado, they said, hey, this is basic math. The answer is 14. And then I have another person from Louisiana that says, hey, it's simple math. The answer is 56. Well, if it was so simple, why do we have so many different answers? So in your interactive journal, I'd like you to add the essential question, why is order important in a global society, and how is it used in mathematics? So let's ask ourselves, why is order important, even outside of mathematics? Can you think of a daily activity that requires order? Well, when I think of it, I think of brushing my teeth. Okay, I do that on a daily basis. Hopefully you do too. So what are the steps I brush my teeth? Well, first I need a toothbrush. I take it out. I put some toothpaste on it. I get it wet with some water. And I ended up brushing my teeth for about 2 minutes. Go ahead and rinse my mouth and then floss sometimes. So the question is, that's my result. The question is, what would happen if I were to switch up that order? Let's say I start by rinsing my mouth, then I floss my teeth, I take out my toothbrush, I brush my teeth, I get it wet, and then I put the toothpaste on at the very end. What would happen? Well, I'd be left with possibly a mouth that looked like that, kind of nasty. Yikes. So there is some importance in order. And math is considered a universal language. That means that everyone across the world uses the same numbers and operations, the same rules, if you will. Okay, so whether you're in Mexico, whether you're in China, the United States, or Japan, all the operations remain the same and numbers keep their same values. So we use order of operations to make sure that everybody gets the same answer. Okay, and here's a definition of order of operations. You can write this definition, you can look up your own, you can put it in your own words, but basically it's a way that we evaluate math so that we get one correct answer. In your journal, I'd like you to go ahead and add to that, what are some of the examples of order in life, maybe outside of mathematics? We wrote down brushing your teeth. See if you can come up with a few more. I have changing a light bulb, performing surgery, and repairing a car. After that, you have your definition for order of operations, whether it's the one from the textbook or you found your own. Okay, so make sure you're up to date with your journal. So let's recall ways that we use to remember the order of operations. You've probably heard this before. Please excuse my dear Aunt Sally. It's an acronym where each letter stands for something. So the P starts with parentheses. Now, this is not just parentheses. This here is a parenthesis. But we also have, brackets. These are called brackets. These are braces or division bars. So all of these are considered grouping symbols under the parentheses. Next is exponents. Okay, you've seen exponents before. Multiplication and division happen to come, whatever comes first, from left to right. That's why I colored them the same. And addition and subtraction also come left to right. So it's not always multiplication that comes first before division, right? It's whatever comes first, left to right, when you're reading it. Same is true about addition and subtraction. Addition isn't always first. It depends on what comes first, left to right. We're going to look at some examples of what that looks like in just a moment. So watch me do one problem here. Taking a look at this expression, I think to myself, PEMDAS, what should I do first? Well, PEMDAS tells me parentheses or any grouping symbol. Well, there are none, so I can skip that part. Next is exponents. Do I have any exponents? Yeah, I sure do. It's right there. So 3 squared, I got to think of what 3 times 3 is, and that gives me 9. So I can replace that with 9. Next, multiplication or division. So here we go. Well, multiplication, division, well, I first see, remember, left to right. The first thing I see is the division bar. And then I see a multiplication bar. So that means I'm going to divide first. So 27 divided by 9, that gives me my 3. And then I can multiply that 3 times 2 to give me 6. And last but not least, addition. Well, there is no addition, but there is subtraction. And so I can subtract lastly and come up with 5 as my final answer. Why don't you try one on your own? 20 plus 8 minus 6 in parentheses minus 4 squared. See if what you come up with. I jump over to my journal here. The first example, I went ahead and wrote it all out with the steps. But here's the next example that you tried. So first, parentheses. Is there parentheses? There sure is. 8 minus 6. So I'm going to do that first. That gives me 2. Next, are there any exponents? There sure is. 4 squared is an exponent. 4 times 4, that's 16. Put that here. Next, is there any multiplication or division? No, there is none. So I would skip that part. Is there any addition or subtraction? Yeah, there is. But addition shows up first, so that's what we do first. We add first. And then we would subtract. And you come up with an answer of 6. Try this next one out. Write them out and follow the steps. Okay, in doing this problem, I start with parentheses. Yes. Now, in the parentheses, before the parentheses, actually, there was a grouping symbol, the division bar, right here. See this division bar? That means to divide those two first before you move on. And so that's what I did first. 26 divided by 2 is 13. Next, I look inside the parentheses, and there's actually 2 things happening here. There's an exponent, and then there's a subtraction. So we have to do that in order. Exponent first, which gives us 4, and then subtract those numbers, which gives us 2. Next, you ask division or multiplication. Yes, there is. Multiplication shows up first as I go from left to right. So I do that first. 5 times 2 is 10. And then division. 10 divided by 2 goes back to 5. Last but not least, any addition and subtraction, well, that's the only thing left is to add. And you come up with 18 as your final answer. So lastly, I'd like to come back to our original question that was posted online. So many people got wrong. Take a look. I think you can do it. Step by step, try to answer this question. Okay, so I'm going to go and work through this. Let's see if you get it right. I take a look. Are there any parentheses? No, no parentheses. Next, are there any exponents? No, no exponents. Next, multiplication and division. Aha, this is where a lot of people make mistakes, but you won't. Yes, there is multiplication, division. As I move from left to right, I notice that division shows up before multiplication. So guess what? That means I need to divide first. So I'm going to take these two 7s, divide them, and I get 1. Next would be your multiplication. So multiplication, that shows up right here. And so I need to do that next. Before I do any addition or subtraction, I'm going to multiply 7 times 7, which gives us 49. Now, I'm going to say, okay, done with multiplication division, but I do have addition and subtraction left. So I'm going to go ahead and add first. So 7 plus 1, that gives me my 8. And I still need to add some more before I subtract. 8 plus 49 gives us our 57. And finally, you would subtract 57 minus 7 gives us 50 as your final answer. I have one last challenge question for you. Can you figure out the mistakes or errors of the online entries for the 7's order of operation problem? In the very beginning, those people from New York and Louisiana and Colorado, can you go back and figure out what they did wrong?